Sir, it's me Aditya of class 9 C ROLL-03 to present a presentation based on the topic Newton's third law of motion. Now I would like to start my presentation. Newton's third law of motion states that every action has equal and opposite reaction. It means that when one body exerts a force on another body, the first body experiences a force which is equal in magnitude in the opposite direction of the force which is exerted. The above statements means that in every interaction there is pair of forces acting on the interacting objects. The magnitude of the forces are equal and the direction of the force on the first object is opposite to the direction of the force of the second object. Now we will perform an activity to prove third law of motion. Aim to study the third law of motion using two spring balances. Materials required for the activity: two identical spring balances, weight box, inextensible thread, a frictionless pulley which can be fixed at the edge of the table, and a pan of unknown mass. Procedure: find the range and at least count of the two spring balances. Ensure that the two spring balances are identical. Check whether the spring balances can measure the force. If the two spring balances have the graduation marking in items of force units, well, if not, that is the spring balances have graduation markings in terms of mass only, then learn to convert it in force unit as explained in the note of the teacher. Hold the two spring balances vertically and ensure that their pointers are of 0 mark. Arrange two spring balances A and B, pulley, and a pan with the help of an inextensible thread as shown. The spring balance B must be attached to a rigid support. The spring balances may rest on the smooth tabletop while the thread must not touch the tabletop. The other end of the thread which is attached with the pan should also freely without touching the table. Sixth step: what are the readings of the scale on the two spring balances? Are they equal? Is it approximately equal to the weight of the pan, mass of pan, or acceleration due to gravity at your place? 7. Identify the action and reaction forces. The force which a spring balance A exerts on B is action. Reading on the scale of a spring balance B. The reading on the scale of balance A shows the reaction of that spring balance B exerts on A. Put some M on the hanger, 100 gram. The total mass attached to the thread is now M plus M. Observe the readings of both the balances. Repeat a step for at least 5 or more masses of the pan. Tabulate your observations. After we will perform the activity, our observation will be that the reading on the both the balances are same in each case. Thus action and reaction are equal and opposite and act on two different bodies. Now I would like to start my second presentation, which is about uniform circular motion. What is uniform circular motion? The movement of a body following a circular path is called a circular motion. Now the motion of a body moving with a constant speed along a circular path is called uniform circular motion. Here the speed is constant but the velocity changes. Now I would like to explain how centripetal force is associated with uniform circular motion. Newton's first law of motion states that an object moving at constant speed will continue that motion unless acted on by an outside force. This means that circular motion can only happen if there is a center seeking force. Otherwise, things would just travel in a straight line rather than curved line or a circle. Centripetal means center seeking. So, centripetal force is used to refer to the force experienced by an object traveling in a circle. For example, when someone spins a ball attached to a rope horizontally above his head, the rope transmits a centripetal force from the muscles of the hand and arm, causing the ball to move in a circular path. Centripetal forces cause centripetal acceleration. In the special case of Earth's circular motion around the sun or any satellite circular motion, any celestial body, the centripetal force causing the motion is the result of a gravitational force between them. Now here we can see a figure which shows uniform circular motion. Thank you. I hope you like it. At last I would like to express my conclusion. I would like to express my special thanks of gratitude to my subject teacher Mr. Manoj, who gave me this golden opportunity to complete a wonderful project on the topic motion. I came to know many wonderful things from this project like about centripetal force and third law of motion. Secondly, I would like to thank my parents and friends who helped me a lot in finalizing this project with a limited time frame. Thank you, sir.